Okay, so looking at this first one, we have the two sides of the equation, and they kind of help us out on this first one. It says, let assume that a equals 1. So basically, we're left with x squared plus 4. And then I'm going to go ahead and FOIL this together right here. And so that's going to give us bx squared plus 2bx, and then we get a plus cx, and then plus 2c. And so what we want to do here is we kind of just start with, we'll just kind of go in order of our power. So we've got 3x squared here, and so we have an x squared and a plus bx squared here. And so those are going to have to be equal to each other. And so we can kind of set up a little equation right here. So 3x squared equals x squared plus bx squared. So if I were to go ahead and solve this, let's see, I'd subtract an x squared from both sides, and you can pretty much tell what it's going to be at this point. So 2x squared equals bx squared. So b is going to have to be equal to 2. Okay, so next we'll look at the x's. So we have a positive 2x here. So 2x equals, and then what we have on the right side, let's see. We have 2 times b times x, and then a plus cx. So let's see, 2 times b times x, and I have a plus cx. And so luckily we know what b is, so we can go ahead and plug it in right here. And so when I do that, that will turn this into a 4x plus cx. And then once again, we're just going to go ahead and start solving for the c value. And so we end up getting negative 2x is equal to cx. And so that must mean that c equals negative 2. And so we can check that to make sure, because we can continue going. And so basically there's nothing left on the left side, but you could kind of basically, what's going to happen is the constants are going to have to turn into 0, because I don't have a constant on the left side. So this equation would be that 0 equals, and let's see, I've got a 4, and I've got plus 2 times c. Well, we figured out that c equals negative 2, so that would make this 0 equals 4 plus negative 4, which is a true statement. So that's a way you can kind of check yourself at the end to make sure, we did everything right. And so anyway, so when you put in your answer, it's just going to be 2 comma negative 2 to make sure you put it in the right format for D2L. Okay, so let's look at the next one. The next one, it's kind of going to be a similar process. It is a little bit more challenging because they don't tell us what A, B, or C is. So we're actually solving for 3 variables. Um, and so they're going to kind of give us a starter to kind of help us kind of get the ball rolling. And so it says use the convenient x value, x equals 1. And that should help kind of make things a little bit easier here. So let's go ahead and see what we got here. So when I plug in a 1, 3 times 1 is 3, plus 1, that would become a 4 right here. This would become a, if I plug in a 1 here, 1 squared, 1 plus 1 is 2, so I've got 2 times a. And then plus, this would become, well, let's see, I gotta FOIL this together actually. But it, or actually, you know what? I'm not gonna FOIL it yet. So let's see, this would become b plus c times, and then 1 minus 1, let's see, that would actually, okay, this might actually work out really nicely here, because that's going to make this go away. So we're left with this equation right here. And so when I divide by 2, a equals 2. Now that we have that a value, that should kind of help us out. So kind of like the other problem, I'm going to go ahead and plug that in and look at the two sides, and then we're going to kind of go from there to solve for b and c. So let's see, if I let a equal 2, so let's see, I've got the 3x plus 1, and then if a is 2, let's see, that'd be 4, I'm sorry, let me see, I'm going to go ahead and distribute that, I'm sorry, so let's see, that'll be um, 2x squared plus 2. So what I did was I plugged in my a value right there. Now I am going to go ahead and FOIL that together. And so let's see, we get a plus bx squared minus bx plus cx, and then minus c. And so we can start with the high powers right here, the x squareds. And so you notice I don't have any on the left. And so what's going on here is I basically have 0x squared on the left side. And so I have 2x squared here minus bx, I'm sorry, plus bx squared right here. And so I'll go ahead and solve that real quick. So let's see, we could subtract 2x squared from both sides. And you might be doing this in your head, and that's fine, but I'm just go ahead and show my work on this. And so then when you divide off the x squareds on both sides, you're going to be left with the b equals negative 2. So now we have a and we have b. So now we got to figure out our c value. So let's see, we can, well, the easiest thing, but we'll probably double check this just to make sure, but the easiest thing I can see right here is that I have the constant of 1, and I have, I only have, well, okay, I have the, I gotta be careful, I got the plus 2, I almost didn't see that. And then I've got the plus, or minus c right here. So I'm gonna go ahead and put that equation together real quick. I'll do it right up here. So let's see, we got 1 equals 2 minus c. And so let's see, we'll go ahead and subtract 2 from both sides. So we get negative 2 equals negative c. Divide both sides by negative 1. And so we get, oops, I'm sorry. Should be a negative 1 right there. So that's a negative 1. Then we divide by negative 1 to make it positive. So c equals 1. And then if we want to be really careful and just make sure we got this right, we're going to go ahead and take the part with our linear term, the 3x. So 3x is equal to negative bx plus cx. And so what we'll do is we'll plug in what we solved and see if it works out well. So this will become 3x equals, so the negative is there, so it's actually going to become negative 2x plus, and then I have 1 x right there when I plug in the c. And so the double negatives are going to cancel out and become positive. Oops, I'm jumping ahead. Positive 2x, and then I'm going to add an x to that. And sure enough, that equals 3x. So I know I got my 3 values correct there. So I hope that helps. If you got some more of them, just, feel free to email me.